Hello viewers, welcome to Big Boy Physics. Today in this video I have taken an interesting problem from mechanics. I have taken this from a Reputed Coaching Institute test series papers. So let's get started. The question says, as shown in the figure, a non-stretchable string of length 2L has one end fixed to a nail at point A and a small ball is tied to the other end. The small ball can move in the vertical plane. Initially, the ball is on the same horizontal line with A and is launched with initial velocity v0 straight downward. To the left of point A at a distance L, there is another nail at point B. When the string passes over point B, the ball will move upwards. You have to report the minimum value of initial velocity v0 for the ball to eventually collide with the nail at point A. And its root alpha is the answer is to be find answer is to finding the value of alpha. You have to find the value of alpha to get the answer. So let me explain the situation, what's occurring. I hope most of you have got it, and those who haven't got it, I'm explaining. This thick dot represents a ball. This thick dot represents a ball, and this ball goes in a circular manner until it reaches the other diametric endpoint. Now here what happens that the string will make a contact with this nail B, and this nail B will apparently act as a pivot. Okay, and now the ball will apparently undergo circular motion with respect to B, and hence you have to find the required parameters so that it hits point A. Pause the video, give it a try for a few minutes. So now discussing with the solution. So first I'll be discussing a method which most of you may have done in this problem. Let me see how many of you have got this wrong. Method 1. Method 1, the intuition is such that when the ball is imparted such velocity, that is it's 2L, it will be L. So my trajectory will somewhat look like this, and then it will have be at a height L from the horizontal line. So half m v naught square, half basically here it must undergo circular motion. It must be liable to undergo circular motion. Then you will get um, m v naught square minus 2gl upon L is equals to mg. From here, cancelling all the terms and getting the result, v naught is equals to root 3gl. Yeah, most of my batchmates also got the same answer, that is root 3gl when we attempted the test. And yeah, surprisingly we got a 0 marks out of 3 or 4. I guess it was out of 4. Out of 4 we got 0 in this question when we marked alpha is equals to 3. Well, 3 is not the answer. Then what is the catch in the problem that is making our answer to be mistaken? So now discussing the correct method. Method 1 is wrong. Method 2, that is correct. I'm making a fresh diagram. This is point A, this is point B at a distance L from point A. Uh, this is L. Now this A from point A to the bead connects a string, and the question is saying that you have to hit point A after the string rolls around peg B. Then what will happen will we thought in the previous question is that the this will be the first trajectory, that will be circular. Now second trajectory, what we thought will be another circle, and then safely to hit point A. But my question is that is it necessary that for the velocity to be minimum, the other trajectory has to be circle? Can it be something like this? The string will go slack at some point, and then it will undergo parabolic trajectory. Till the orange part I'm marking is a circle, then it undergoes a parabola. This is another case possible. So yeah, that's the catch in this problem. That in the middle, the string will start to getting slacked, And another theorem involved in this question is that suppose you have a circle. I am drawing a perfect circle using shapes option. You have a circle, and this is not a solid circle. This basically represents the trajectory of a mass, point mass, which is rotating under the influence of some other external forces. We're basically trying to rotate this bob. Then, if it leaves the circular track at some point P, if it leaves the circular track at point P, and at point P it makes an angle theta with the vertical, then it will again hit the trajectory at some other point P dash, which makes an angle 3 theta with the vertical. Now both the angles are measured from the same line. This is one thing to be noted down. Both the angles are taken from the same line, and this angle, new angle, at which it will hit the circular track will be 3 theta. This is the concept required. Now, considering this to be the vertical, this is the circle. Just a minute. Yeah, so this is my circle, and one minute. Yeah, this is my circle, and I'm shifting the point B a little so that the diagram looks good to scale. And this is the point where its leaves is theta. Then the point at which it hits the circular trajectory will be 3 theta. So 3 theta should be equal to 90 degrees. Hence we'll get theta is equal to 30 degrees. So we can conclude that when the mass is at an angle of 30 degrees with respect to the vertical, then the mass would leave so that it just slacks the string and hits the point A. That means that mg cos theta mg cos theta is equals to mv square minus 2g into L. Just a minute. Yeah, mg cos theta 2g into L cos theta by L. So basically, uh, this is the centripetal acceleration, and this is the force along the radial direction. From here, you will get velocity. Velocity is equals to root 3gl cos theta, and putting theta is equals to 30 degree, we will get under root 3 root 3 by 2 gl. Hence, alpha would come out to be 3 into 1.73 by 2, and if you try to evaluate it, you will get it nearly to be 2.6. And that's the answer to this question. Well, the proof for theta and 3 theta, I will be coming up with some other video regarding the proof. So till then, I hope you understood this problem, and you must digest this relation theta and 3 theta. Okay. So hope you enjoyed this video and learned something new, and learned that how JEE questions can trick us if we go through ROT derivations and all those. We need to apply our brain and be free with thinking while attempting a JEE paper rather than being in a pressurized mode and just applying the formulas. So thank you. Have a nice day.